All right, Module 9.1, adding and subtracting rational expressions. Given a rational expression, we're going to identify the excluded values by finding the zeros of the denominator. That's the technical term. We all know we can't divide by zero. If you try on your calculator to divide by zero, you get an error. So we're going to try to figure out what's going to make that happen. So what values of x would make the denominator 0? So in other words, what values of x are going to blow up your denominator? So we have this example. We have 1 minus x squared over x minus 1. For now, I don't really care what's in the numerator. I only care about what's in the denominator. I want to look at the values that are going to make this 0. So what can x not be? X minus 1 cannot equal 0. Otherwise, we've blown up our denominator. So we set up an equation. Whatever's down here, we set it not equal to 0. And we solve it. We add 1 to both sides. So that means x cannot be 1. This is called our excluded value. Here's another example right here. 4 over x squared plus 4. So x squared plus 4 cannot equal 0. Move the 4 over, so we get x squared cannot equal negative 4. And when you square root it, you no longer have a real number. So this doesn't have any excluded values because we have nothing that is a real number. Since there is no real numbers where x can be equal to negative 4, we're done. We're good. Over on this one, we're going to write given expressions as equivalent rational expressions that has a given denominator. So this is the denominator we have. This is the denominator we want. So we're going to take 3 over x plus 3, and we want to write it as x plus 3 times x plus 5. So we want to change that denominator. Well, we have to look at, this one has the x plus 3, this one has an x plus 5. So to make them the same, I have to multiply the top and the bottom, both numerator and denominator, by the same value. Distribute your 3, you get 3x plus 15. Now, this fraction is equivalent to this one. Remember, equivalent fractions. 2/4 is the same thing as 1/2. They look different, but they mean the same value. So example 4, we're going to take this one and make it as a denominator of x minus 5, x plus 1. So first things first, we have to actually simplify this denominator. So we have to refactor out the 5, and we get x minus 5 on the inside. What happens to my 5s? They cancel. Remember, when they cancel, they don't just disappear. It becomes a 1. So the reduced one now is 1 over x minus 5. I want to make that look like x minus 5, x plus 1. So I need to look at it in terms of what is it missing? What is this one missing that this one has? The x plus 1. So we're going to multiply the top and bottom by the same thing, just multiplying by 1, so that simply becomes an x plus 1 over x minus 5 times x plus 1. They're equivalent fractions. Equivalent rational expressions. Now, this one wants us to simplify. Okay, to simplify means we actually need to do some factoring. So looking up here at the numerator, I can take out an x, and that's x, or excuse me, not x, it would be 1 plus x squared. This factors to x minus, or 1 minus x, and 1 plus x. Denominator, I'm going to take out an x squared, and that leaves me with an x, leaves me with a 1 minus x to the 4th. This factors down even more. So again, my numerator, change pens, we have an x, I have 1 plus x squared, 1 minus x, 1 plus x. On the denominator, I have an x times x, because that's what x squared is. This little thing factors to 1 minus x squared, 1 plus x squared. This one factors again. So the total factor goes 1 plus x, 1 minus x, that's this one, and then 1 plus x squared. Now, the fun part is we get to cancel out all the little things that are common, that are being multiplied. So this x can cancel with one of those. I have a 1 plus x squared here and here. I have a 1 minus x. I have a 1 plus x. Everything on the top canceled, which means the numerator now becomes 1. The only thing I have left in the denominator is x. So there is the simplified version. All right, and our last, finding the LCD. LCD is the least common denominator for this expression. To do that means I need to factor everything. So this is negative 2 over 3 times x minus 5. Here I have 6x, taking out a 4, I have x plus 7. So I want to look at this and I want to find the LCD. So I need one of everything. I need a 3, I need a 4, I need an x minus 5 and x plus 7. So my LCD is 12, x minus 5, x plus 7. I need one of each term. We're going to look at one more where we're finding the LCD. So we're looking at these two, finding an LCD. Make sure everything's factored. 12x. Factor out 15 on the denominator, so we get x plus 4. Over here, we're going to factor that denominator to x plus 4, x plus 5. Now, they have an x plus 4 in common. That's great. So I need to look at what the LCD would be, the least common denominator. We need a 15, 1x plus 4, and because this one has the x plus 5, we need to tag it along. So there is our LCD.